Okay, this is Mr. Anderson from Kellogg Community College. We're going to be looking at page 5 of the test review. And what we'll do here is start off with problem number 18, where we're supposed to solve for the letter t. And you'll notice that we actually have two t's in the problem. And my first suggestion is anytime you see a denominator here, you may want to clear the denominator. So the denominator is r minus t. So if we multiply r minus t on both sides, what happens is that the r minus t's simplify on the right side, and on the left side we have k times the quantity of r minus t is equal to now rt. And we've gotten t out of the denominator, but we still need to do a little bit of mathematics here. So kr minus k and the letter t is equal to r times the letter t. And what we will then do is we will then get the t's together because we need to get the t's by themselves. So I'm going to add the kt to both sides. And this will get my t's on the same side of the equal sign. And simplify here. So kr is equal to kt plus, or that should be a t there, kt plus rt. And since my goal of the problem is to solve for t, I'm going to get the t all by itself. So I'll take my t, factor it out, so I have k plus r is equal to, or times t is equal to kr. Now my last step of the problem to get t all by itself is to divide both sides by k plus r. Now what this will do is this will simplify the k plus r's and leave me with t on the right hand side. So t is going to be equal to k times r over k plus r. And this matched a lot of your problems in your homework section that you had. Now here's a problem that deals with Hooke's law, and it states that the distance d that the spring is stretched by a hanging object varies directly with mass m. Now direct variance is done by the equation y equals kx. So now it says if the distance is 20 centimeters when the mass is 3 kilograms, okay, what is the distance when the mass is heavier? 5 kilograms. So we're going to plug in our 20 equals k times 3, and we're going to do this to figure out what my k factor is. Divide both sides by 3, and this gives me k is equal to 20 thirds. Now I'm going to leave that as a fraction because I can get a much better answer when I plug it into, when I actually answer the question for 5 kilograms. This is y equals 20 over 3x, and now I'm going to figure it out for 5. Now I'm going to plug that 5 in for my x right there. So y is equal to 20 thirds times 5. And multiplying fractions not a problem. Top times top, bottom times bottom. So y is equal to 100 thirds, or roughly 33.3 centimeters in distance. All right, and that's how you do number 19. Now in problem 20, we have a problem that this is a little bit more straightforward. It talks about an inverse relationship here because it says find the variation constant, so find k, and the equation of variation in which is the equation of variation is y equals k over x. Because this is basically given to us here where it says y varies inversely, so that verifies this formula right here, as x when y is equal to 27 and x is equal to 1/3. Now the easiest way to do this, since you're dividing by a third, is to multiply both sides by 1/3. And you can type it into the calculator just like this, parentheses 1 divided by 3, parentheses 27, and that's going to give you an answer of 9 equals k, because 1/3 of 27 is 9. And it says here, find the variation constant, so we've done that, and equation of variation, so it's going to be this here. So we're going to go y equals 9 over x. So there's our two parts of the problem. And remember it said inversely in the problem, so it's going to be this equation. Directly is y equals kx, inversely is y equals k over x. Alright, in the final problem here on page 5, it says the pitch of a musical note varies inversely with wavelength w. So here's my equation then, k over x. There's the inverse equation. One note has a pitch of 330 vibrations per second, and a wavelength of 3.2 feet. Okay, so that's again going to be set up into my equation, k over 3.2. because this is my P and this is my W, the wavelength. Find the pitch of another note that has a wavelength of 1.92. So our first step is to figure out what K is. And so what I'm going to do here is multiply both sides by 3.2. Those go away. 3.2 times 330 is going to be 1056, and that's going to be my K. And therefore I have my equation now of y equals 1056 divided by x. Now it says find the pitch of another note that has a wavelength of 1.92 feet. So y is equal to 1056 divided by 1.92. And so this is going to give me y is equal to, dividing these two here, this is going to give me 550 vibrations per second. So that's the pitch of the note, 550 versus the original note, which is 330. And that's the end of page 5. Thanks for watching.